Hello everyone, in this video we'll be solving problem 97, interleaving strings. The problem statement is to figure out if we can build string S3 by interleaving strings S1 and S2. Interleaving means that we need to take the characters from S1 and S2 in the same sequence and try to build string S3. If we look at example number 1, we can take the characters from string S1 and S2 and build string S3 while maintaining the sequence in which the characters appear in the respective strings. For instance, the first two characters A and A are taken from string S1, while the next four characters are taken from string S2. Please note that we are not breaking the sequence in which we are extracting the characters from the respective strings to build S3. As we used AA from S1, the next available character in S1 is B. We are not supposed to take any other characters besides B from S1. There's a lot more theory given in the problem statement to understand the conditions. I hope the explanation I provided was helpful. Let's switch to whiteboard and discuss how we can solve it. Let's use this as our example where this is S1, this string is S2 and this string is S3. Like every other problem, this problem can also be solved using brute force, where we'll use two pointers, one pointing at S1, the other pointing at S2, and each of their corresponding characters will be compared against the characters in S3. If the character in S3 matches to the character pointed by the pointer in S1, then the respective pointer will be incremented by 1. The same check needs to be repeated with S2 as well. If we were able to locate all of the characters in S3 that appears in S1 and S2 combined, then at the end, both of the pointers will be pointing at the element right after the last one in the respective strings. That will be our cue to say that we were able to interleave strings S1 and S2 to build S3. Although this approach is straightforward and easy to understand, there is one edge case that it will not be able to handle. Let me share some details on that. The challenge is that we are comparing the character in S3 with either S1 or S2. Because we are only comparing with either of the two, there is a possibility that we may not get accurate results at the end, as it is possible that the characters that the two pointers are pointing in S1 and S2 both match with the character in S3. In this example, if we look at the first two characters in S3, they both match with the first two characters in S1. So our first instinct is to take the characters from S1 and increment the corresponding pointer to point at B, which is the next character. So far it is good, but if you look at the next character in S3, it is X, and neither of the two pointers are pointing at a character that matches the value. So ideally, we should stop the iteration here and return false. But this answer is incorrect. If we would have picked one A from S1 and the other A from S2, then the pointer that S2 is using will be pointing at the character X, which matches to the next character in S3. So we would have continued the iteration to check for the remaining characters in S3 to verify if we can interleave. As you can see, we can't just compare the characters in S3 with either S1 or S2. We need to compare it with both if the values are equal. Let's do a quick dry run using two pointers, where one pointer will be pointing at the string S1 and the other will be pointing at S2. We technically do not need a separate pointer for S3 because the pointer in S3 should be the sum of the pointer values of S1 and S2. We start by comparing the value in S3 with the characters in S1 and S2. As we discussed earlier, it is possible that the character in S3 is equal to the character in S1 and S2. In that case, we need to explore both of the possibilities, one when we are extracting the character from S2 and the other for S1. This resembles like a decision tree where we have two options we need to explore. Depending on from where we are picking the character, we'll increment the corresponding pointer in S1 or S2 and try comparing the next character. This comparison will continue until we have validated all of the characters or any of the character in between do not match. With this solution, our time complexity is O of 2s to power m plus n, where m and n is the size of strings S1 and S2. The reason it is 2 raised to power m plus n, it is because we are creating this decision tree with two possibilities. One is if the character matches with S1 and the other being character matching with S2. And the space complexity is O of 1, that is constant space, because we are only using couple of pointers, one to point at S1, other for S2, and the third would be for S3. As you can see, the time complexity of this solution is very high. Now let's discuss some optimization to improve our time complexity. The reason the time complexity of this solution is very high is because we need to explore all possibilities if the characters matches with S1 and S2 respectively. And as part of those checks, it is highly likely that we will end up doing some duplicate calculations that have already been done. For instance, the combination of S1 and S2 pointers processed by the right leg might have already been processed by the left leg. The biggest issue here is the right leg does not know or is aware of if the same combination have already been executed. So we need to introduce some sort of a caching logic into our algorithm which will help us store the results and do a quick lookup to verify if a certain combination of the pointers have already been executed or not. If it has already been processed, then we can skip processing it again and just extract the result from the cache. To be more specific, we are introducing dynamic programming using caching into our algorithm. Because we are working with two pointers for S1 and S2, the key for the cache should be the combination of the two so that we can do a quick lookup and while making sure the entries are unique. For this discussion, let's call it I and J. With this improvement, the overall time complexity of this approach is O of m plus n, where m and n are the number of characters in string S1 and S2. While the space complexity is now O of m into n, that is the product of m and n. This is based on the maximum size of the cache that we added. As this cache will contain all permutation combination of values between S1 pointer and S2 pointer, the size or the space complexity of this approach is going to be the product of m and n. For example, if I have two strings S1 and S2 of length 3, then the combination or the keys will start from 00 all the way to 02, and then we'll increment the first pointer, that is 10, 11, 12, and so on and so forth. I hope you are able to understand this explanation. Let me show you how we can implement this using Python. In this Python implementation, I start by adding a validation to make sure that the length of S1 plus S2 is equals to S3. If not, then I can simply return false. After that, I'm initializing the cache component. I've created this helper method can interleave, passing the index or the pointer for S1 and S2. Inside this method, the first check is to validate if S1 and S2 index is equal to the length of the respective strings. If yes, it means all of the checks have been successfully passed and we can return true as the output. If not, then I'm checking if the combination of S1 and S2 as a key exists in the cache. If it exists, I'm returning the corresponding value as the output. And if not, then I'm calculating the S3 index on the next line, which is the sum of S1 and S2 indexes. Next step is to compare the character pointed by the S3 index with the character pointed by S1 index. If the values are equal, then I'm calling the can interleave method recursively, incrementing the S1 index by 1. If the result is false, then I'm repeating the same check, but this time I'm comparing the character in S3 with the character in S2. If those two match, then I'm calling the can interleave method again, but this time I'm incrementing the S2 index by 1. The results of the two recursive calls is being saved into the cache. This helper method will return true only if we were able to interleave strings S1 and S2 to form S3, or else return false. This code, when submitted on LeetCode, beats nearly 41% of the submissions in terms of runtime and nearly 30% in terms of memory. Thank you for watching this video. I hope you are able to understand the explanation. The details to access the source code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.